the preparation of only aldehydes. Okay. In the earlier class, we have discussed about the preparation of both aldehydes and ketones from the same method. Okay. Here we are going to discuss about specific methods to synthesize aldehydes only. Okay. Let us consider one by one. The first one is preparation of aldehydes from acid chlorides by Rosenmund reduction. Okay. What is the first method? That is from acid chlorides. From acid chlorides by Rosenmund reduction. What is this method called? Rosenmund reduction. Rosenmund is a scientist. He invented this method. So the reaction is given on his name. Here we are going to use the Lindlar's catalyst. Let's see what is that method and what is Lindlar's catalyst. Okay. When acid chlorides are treated with hydrogen, okay, when acid chloride is treated with a hydrogen gas, okay, in the presence of the catalyst, palladium is treated with barium sulfate in the presence of sulfur or quinoline. Sulfur or quinoline. Okay. Why the barium sulfate, sulfur or quinoline is used? To control the activity of palladium or to inactivate the activity of palladium to its off or partially deactivation of palladium is done by treating with barium sulfate in presence of sulfur or quinoline. Okay. What happens here? The Cl will be replaced with the hydrogen, so you will get Cl(OH). This is called as aldehyde. Okay, this is called acid chloride, or it is also called as acyl chloride, and it is aldehyde. It is aldehyde. Here R may be alkyl or aryl group. Alkyl or aryl group means by the Rosenmund reduction you can get the aliphatic aldehydes or aromatic aldehydes. Let us see some examples. Okay. Yes. The first one is take alkyl group, for example CH3. In case of R, so there should be CH3 C double bond to Cl. It is called as acetyl chloride or ethynyl chloride. Common name is acetyl chloride. IUPAC name is two carbon atoms are there, therefore ethynyl chloride. Ethynyl chloride. Say, remembering the common names and IUPAC names is very easy. You need to practice. Okay, you need to correlate with one another. Then it will become very easy. Okay, you have to question everything to learn new things. Okay, you have to question this: why it is called as acetyl chloride? Why its IUPAC name is ethynyl chloride? If you go on questioning yourself, then you will build up your knowledge, okay, automatically. Okay, this you have to do. Okay, for the CH3CO group we call it as acetyl chloride. Okay, and in the IUPAC it is called as ethynyl, okay, chloride. Okay, yes, when this is treated with the hydrogen gas in the presence of a Lindlar's catalyst, that is partially deactivated palladium using barium sulfate in the presence of sulfur or quinoline. Sulfur or quinoline. Okay. So what happens? You will get. You can see the replacement of this Cl with H. Okay. So you will get CH3 E double bond H. What is this? Ethanol or acetaldehyde. This is acetaldehyde or ethanol, where Al stands for aldehyde. Okay, this is what aliphatic aldehydes are obtained from this Rosenberg reduction. Now let us see the aromatic. To get aromatic, here aromatic ring must be present in the place of R, that is benzoate. Okay. This is called as benzoyl chloride. This is called as benzoyl chloride. When benzoyl chloride is treated with hydrogen in the presence of the Ringloff catalyst, okay, in the presence of sulfur, you will get the benzoyl. Obviously, the byproduct will be HCl. Obviously, the byproduct will be HCl. This is what the benzoyl. Okay, what is the Limlas catalyst? What is the Limlas catalyst? It is a mixture of palladium, barium sulfate, sulfur, or quinoline. Okay, this is very easy and very important for the final examination. This is very important for the annual examination. It is a method of preparation of both aliphatic and aromatic aldehydes. Okay. The next method is preparation of aldehydes from alkyl nitriles. Okay. This method, here you can see two reagents which converts the alkyl cyanides or nitriles into the aldehydes. Let us see one by one. The first one is Stephen's reaction. The first one is Stephen reaction. Here, Stephen, a scientist, he invented the conversion of alkyl nitriles into the aldehydes using a reagent that is a mixture of SnCl2, that is a tin chloride, in the presence of HCl. Okay, it generates the nascent hydrogen atoms. Let us see that. Okay, let us consider this is Stephen's reaction. RC triple bond N. This is called as alkyl cyanide or alkyl nitrile. Okay, we can call it alkyl cyanides or alkyl nitriles. Okay, alkyl nitriles are also called as alkyl cyanides. See, you need to remember everything in the chemistry because the question may be asked from any angle. Okay, they may ask you to explain the conversion of alkyl nitriles to aldehydes or alkyl cyanides to aldehydes. You should not say we don't know what is cyanide, what is nitrile. Okay, here I am giving you the every detail. Okay, remember this. Okay, when RCN, that is alkyl nitrile, is treated with stannous chloride, that is SnCl2, in the presence of HCl. What happens? You will get imine as the intermediate. Okay. What is this? This is alkyl nitrile. Okay. When it is treated with the SnCl2 in the presence of HCl, okay, here this mixture generates the nascent hydrogens like this. When SnCl2 is treated with 2 moles of HCl, you will get SnCl4 plus 2 nascent hydrogens. Here the thing is expanding its covalency from 2 to 4. From 2 to 4. Okay. Therefore, you are getting the nascent hydrogens. Okay. It gives you the imine acid product. Here you got the two hydrogens. Now one hydrogen will attack on this carbon, another hydrogen will attack on this nitrogen. So during addition reaction, the triple bond will be converted into the double bond. No? So you will get RCH double bond NH. This is called as imine. This is called as imine. When it is hydrolyzed in the presence of an acid, for example, this is called as acid hydrolysis. What happens here? This NH will be replaced with the O, so that is CHO, like this. That is aldehyde. Okay, and remaining will be forming NH4Cl, that is ammonium chloride. This is salt. This is salt. Okay, so you are getting aldehyde. You are getting it. Here R may be aldehyde. R aryl group. R may be alkyl R aryl group. So you write the examples by taking R is equal to CH3 and R is equal to C6H5. Okay, that you have to try yourself. Okay. One I will show you here. For example, take R as CH3. CH3 C triple bond. This is called as methyl cyanide, or IUPAC is ethane nitrile. See here, in the IUPAC system, we are counting every number. Okay, every carbon atom. 1, 2, ethane. Here ethane is written as it is. You have to observe this. Ethane, here E is not replaced with nitrile because N should not come successively, one after the other. That is why we have to write ethane nitrile. Okay. In the common system, we are calling this CN as a cyanide. Okay, and this is a methyl. Methyl cyanide is having the IUPAC name ethane nitrile. This you should remember. Okay, when this is treated with SnCl2 in presence of HCl, here you have to take excess of HCl. Okay, then you will get a CH3 CH double bond H. Double bond N. This is a imine. This is a imine. See, what is imine? Double bond NH. When double bond NH group is present, this is called as imine. What is amine? NH2 group is present. When NH2 group is present, that is amine. When double bond NH is present, it is imine. Okay. Yes. When this is acid hydrolyzed. Okay, what happens? This NH will be replaced with the oxygen atom. You will get CH3 CHO acid product plus NH4Cl acid salt. So this is what acetaldehyde. Okay, acetaldehyde is the common name. Okay. Okay, this is all about the conversion of nitriles or cyanides to the aldehydes. Okay. Here we have a very important reagent that is called as dipol H. We have an important reagent that is called as a dipol H. It brings about the selective reduction. Okay, selective reduction of the cyanide group to the aldehyde group. It won't disturb the unsaturation. Okay, it won't disturb the unsaturation. Let us consider the second method of converting the cyanides into the aldehyde using dipol H. Using dipol H. What is dipol H? Dipol here, it is the abbreviation for diisobutyl. D stands for di, I stands for iso, B stands for butyl. Diisobutyl. A stands for aluminum, Al stands for aluminum, H stands for hydride. Okay, diisobutyl aluminum hydride. Aluminum hydride. Okay, diisobutyl aluminum hydride. It can be written as like this. The formula of diisobutyl is this. Di 2 stands for diisobutyl aluminum hydride. Okay, this brings about selective reduction. Means it does not disturb the unsaturation. It cannot affect. It does not affect the unsaturation. It does not affect unsaturation. It does not affect unsaturation. Okay, then we can take a particular example here. CH3 CH double bond CH CH2 C triple bond N. If this is a nitride, what is the name of this nitride? Carbon 1 2 3 4 5. So total 5 carbon atoms in the parent chain, pent. Okay, pent 3 in 1 nitride. Okay, yes, what is the name? Pent 3 in. Okay, see here you have to take the E as it is. Okay, 1 nitride. While giving the IUPAC name, you have to count this carbon also. Now triple bond N is considered as nitride. Pent 3 in 1 nitride. When it is reduced with a diisobutyl aluminum hydride, that is diol H, followed by the hydrolysis. Okay. First you have to treat with the diol H, that is this one. First you have to treat this compound with the diol H. Later you have to add water, that is hydrolysis. So what happens? It does not affect this C double bond C. Simply converts this cyanide to the aldehyde. Okay. So you will get CH3 CH double bond CH CH2 CH2 CHO. Okay, immediately. So what is the name of this compound? Again count the numbers 1 2 3 4 5. Pent 3 in 1 Al. Pent 3 in 1 Al. Pentanol it is called. See here ENE, E of this alkane is replaced with the Al, but here E is kept as it is. That is, for nitriles we have to keep this E. Okay. For other class of compounds you can replace it. Okay. Here, what is the significance or importance of diol H? When this diol H is used, it does not affect the unsaturation. If you use this Stephen reduction, it will affect this unsaturation. Here you are getting, by treating this tin chloride with this HCl, you are getting nascent hydrogen. No, that nascent hydrogen will definitely add on to the unsaturation, and you will get the alkane nitrile. Here it is alkane nitrile. No? Here you will get alkane nitrile, and later it will give the alkanol, which saturated aldehyde. Here unsaturated nitrile is converted into unsaturated aldehyde using diol H, because this diol H does not affect the unsaturation. If you use this SnCl2 plus HCl, it will definitely convert the alkene nitrile to, okay, alkane aldehyde, that is alcohol. Means that unsaturation will be removed from this structure. Okay, this is the importance of the diol H. Let us consider the third method of preparation of aldehydes, that is from esters. From esters using the same reagent, that is dibolage. Using dibolage. So what is dibolage? Di-isobutyl aluminum hydride. Okay, it's nothing but written as this one. Let us consider the examples now. Take CH3, CH2, 9 times. Okay. Why I am taking this particular example? Because it is mentioned in the NCERT and there is a chance for the paper setter to ask the same example. Okay, that's why it will be easy. Okay, take this example. C double bond O C2H5. What is the name of this ester? See, this is an ester, RCOOR dash. Okay, it is an ester. Okay. Now, what kind of ester it is? How to name this? What is this group? Ethyl. Okay, ethyl. How many carbon atoms are on this part? 9. This one 10. This is 11. For 11, we call undec. Undec. Deca is 10. Undec is 11. Dodec is 12. Like that. Okay. So ethyl undecanoate. Suffix for the ester is O8. Okay. So the name of this compound is ethyl. This one undecanoate. Ethyl undecanoate is the name of the IUPAC name of this compound. O8 is the suffix. O8 is the suffix for ester. Okay. Yes. When this is treated with a dibolage, in the first step you have to treat this with a dibolage. Dibolage can be written like this also. Okay. Aluminum hydride, di-isobutyl. So this is called di-isobutyl aluminum hydride. Okay. Followed by the hydrolysis. That is addition of water. So what happens? This part will be broken down to aldehyde. Okay. So you get CH3, CH2, 9 times C double bond OH. What is the aldehyde? Here 9, 10, 11 carbon atoms. So we call this as undeca Al for aldehyde. Undecanol. This ester is converted into the aldehyde using dibolage followed by the hydrolysis. Okay. And the last method is preparation of aldehydes from arenes. What are arenes? Arenes means aromatic hydrocarbons. Arenes means aromatic. Aromatic means it has benzene ring. Okay. Preparation of aldehydes from arenes or aromatic hydrocarbons. Here, firstly, let us consider the conversion of toluene to benzaldehyde using chromyl chloride. That method is called as Ethar's reaction. Ethar is a scientist. He invented this method. So therefore, the reaction is called as Ethar's reaction. Yes, let us take that. Ethar's reaction. And here we are going to use the reagent, that is Ethar's reagent. Let us see that. Okay. When toluene, what is toluene? The methyl benzene is called as toluene. Okay. When toluene is treated with chromyl chloride, in the presence of less polar solvent, that is carbon disulfide. Okay. This chromyl chloride is a gas. Okay. When this toluene is treated with chromyl chloride, this is called as what? chromine chloride. This is also called as Aldehydes reagent. This is also called as Aldehydes reagent. Okay. When this toluene is treated with a chromine chloride, in the presence of carbon disulfide, it is a less polar solvent. Okay. So here this carbon of open chain will be oxidized with this. This is the oxidizing agent. Okay. And it will give a chromium complex. It is brown in color. Like this. CH. Okay. These two hydrogens will be taken by this O. Okay. Here you will get O, here OH, here 2 times. Okay. Carefully observe this reaction. Here totally 2 Cr are there, 4 oxygen atoms and 4 Cl. Okay. That's what here I have taken this as O, CrO, H, Cl2 2 times. Okay. This you need to write carefully. Okay. This is a chromium complex. And brown in color. Okay. And when this is acid hydrolyzed, you will get oxygen atom here. This bond between the chromium part and this carbon will be broken down, and this part is oxidized, that is addition of oxygen. You will get benzoyl as the product. So here I am not giving you the detailed or written explanation. I am not going to give you the written explanation. In annual exams also, whenever the question is asked like this, explain Aldehydes reaction, you have to write the reaction equation with the names corresponding to the reagents. Okay. You have to write the reaction equation with names and you have to explain in writing like this. When toluene is treated with a chromine chloride in the presence of carbon disulfide gives chromium complex. And when it is acid hydrolyzed gives the benzoyl. This much explanation is enough to get full marks. Okay. So here you need to remember everything. What is the reagent used? Aldehydes reagent. What is Aldehydes reagent? Chromine chloride gas. What is its formula? CrO2Cl2. Okay. You need to concentrate on everything. Okay. Yes. The second method of converting arenes to aldehydes is using chromium trioxide. Let us see that. Using chromium trioxide in the presence of acetic anhydride. What is that? Let us see. Let's take down a simple arene, aromatic hydrocarbon, toluene. Okay. When this toluene, here only the carbon of open chain will be oxidized to aldehyde. Okay. Yes. When toluene is treated with the CrO3, that is the oxidizing agent. It is the oxidizing agent. In the previous case also, the chromine chloride gas is oxidizing agent. Okay. In the presence of acetic anhydride, that is CH3CO twice O. This is called as acetic anhydride, and some 10 degrees Celsius heat is required. Okay. As it will be oxidized to the intermediate OCOCH3. OCOCH3 5. This is called as benzylidene diacetate. This is called as benzylidene diacetate. This part is benzylidene diacetate. Okay. Again, when it is acid hydrolyzed, we will get benzaldehyde. Okay, we will get benzaldehyde like this. Benzaldehyde, and the byproduct will be the acetic acid. 2 moles of acetic acid. Okay. What is the product? Benzaldehyde. Benzaldehyde is the product, and acetic acid will be the byproduct. Acetic acid will be the byproduct. Okay. Yes. Here you need to understand the open chain carbon is oxidized with the mild oxidizing agents. Okay, to the aldehydes. Yes. Let us consider the third method, that is by side chain halogenation. Side chain is this. We will convert this to halogenation. Okay, then to aldehydes. Okay, by side chain halogenation. By side chain halogenation. This can be done. Okay, by using the sunlight. Okay, that is electromagnetic radiation. This induces the free radical mechanism. Okay, this reaction will occur through free radical mechanism. Here mechanisms are also very important. This reaction involves free radical mechanism. Whenever you use the sunlight or electromagnetic radiations, homolytic cleavage of a covalent bond takes place that forms the free radicals. Okay. Yes. Take a toluene. Okay. Okay. Here you know these CH bonds will be there. Okay. We are concentrating on that. When this is treated with the halogen, for example, chlorine, excess of chlorine you have to take in the presence of Hg. That is, this causes the free radical mechanism. That is sunlight. Okay. Here you are going to get the CHCl2. You are going to get the CHCl2, means 2 moles of this Cl, okay, will be added there, and here you can take 2 moles. Okay. And also you will be getting the HCl as the byproduct. HCl as the byproduct. Okay. Then this is called as benzol chloride. Benzol chloride. Yes, when this is hydrolyzed with water, okay, O will join in the place of Cl2, and this 2H will combine with 2Cl, and byproduct will be the HCl. Okay, you will get benzaldehyde as the product. You get benzaldehyde as the product plus HCl as byproduct. HCl as byproduct. In all these cases, we are converting the toluene into benzaldehyde by using different reagents. In the first case, atox reagent is used. Here, CrO3 in presence of acetic anhydride is used. Here, chlorine in the presence of sunlight is used. Okay. And here, next case, we shall convert the benzene to benzaldehyde by Gattermann-Koch reaction. Okay. The third method is, the fourth method of preparing benzaldehyde is Gattermann-Koch reaction. These are scientists. Okay, Gattermann is one scientist, Koch is another scientist. These 2 scientists together invented this method. Okay, it is a simple method. They are going to add carbon monoxide and HCl mixture onto the benzene, benzene in presence of anhydrous aluminum chloride. It acts as a Lewis acid or catalyst. Okay, let us see that when benzene is treated with carbon monoxide and HCl, you can take plus or comma anything. When benzene is treated with carbon monoxide and HCl in the presence of anhydrous aluminum chloride or CuCl or CuCl. This is called as cuprous chloride. Cuprous chloride. These two are Lewis acids. These two are Lewis acids and catalyst in these reactions. Okay. What happens? You will get benzoic. You will get benzoic. This is called benzene. See in the annual examinations, the Aldehydes reaction, Rosenmund reduction, Stephen reduction, Gattermann-Koch reaction, these are all very important. These are all very. If anyone asks you to explain the Gattermann-Koch reaction, how do you explain? You have to first write this reaction equation and later you have to explain like this. When benzene is treated with carbon monoxide and HCl in the presence of anhydrous AlCl3 or CuCl, it gives the benzoic. Okay. These are the methods of preparing aliphatic aldehydes, aromatic aldehydes. Okay. Here we have seen the different reagents are used to convert the acid chlorides, nitriles, esters and arenes into the aldehydes. Okay. You need to practice. Dear students, now we shall discuss about the preparation of ketones. Yes, in the earlier class we have seen the preparation of aldehydes. Okay. Similarly, we can convert the acid chlorides into the ketones, nitriles into the ketones, the aromatic hydrocarbons into the ketones. Let us consider these three methods. Okay. First one is from acid chlorides. From acid chlorides. What is acid chloride? It is RCl. When this is treated with dialkyl cadmium, for example, CdR2. Okay. Here, this R and this R may be same or different. Here, how many R you have? R dash, that is 2. That's why we need to take this. Okay, this is 2 moles of acid chloride. When this is treated with the dialkyl cadmium, you will get RCOR dash. Here 2 R's are there, 2 R dash are there. These will combine 2 moles of RCOR dash will get. This is what a ketone. And you have this cadmium and Cl2, it will form cadmium fluoride, a salt. Okay. It's a simple method of preparing ketones from acid chlorides. How to explain this? When acid chloride is treated with dialkyl cadmium, you will get a ketone as the product. Here you may take R as any alkyl group and R dash here R may be alkyl group or aryl group. Okay. You can write this suitable example by taking R is equal to CH. Take R is equal to CH3 and write your suitable example. Okay. This is your homework. And take R dash also as CH3. No problem. Okay. Take R and R dash as CH3 and write the reaction equation so that you will get a acetone as the product. You will get acetone as the product. That you have to do as a homework. Okay. Secondly, we shall prepare the ketones from nitrates. from nitriles. Okay. Take the nitrile. What is nitrile? RC triple bond N. Take the RC triple bond N. This is called as alkyl nitrile when it is treated with a Grignard reagent. For example, CH3 MgPr. Okay. What happens? Addition reaction takes place where triple bond will be converted into the double bond, and you know that this is the most electronegative nitrogen. This will be delta minus, this will be delta plus. This is delta minus, this is plus. Okay, because it is a metal, no plus. Take it plus. Minus alkyl group will attack this carbon. Okay, this positive part will be attacked on the nitrogen, so you will get R, you get R. During addition reaction, the triple bond will be converted into the double bond. Okay, C double bond, and this will become MgBr, NMgBr. And this is going to attack, so therefore this is CH3. Okay, and when it is hydrolyzed, what happens here? Adding H2O is like this. You will get C double bond like this. So this will be R2CH2. Okay, plus NH2 MgBr. This is what a ketone. This is what a ketone. Here also you may take R and R dash as alkyl aryl. R is equal to alkyl aryl group. Okay, this is how we are going to convert the nitriles into the ketones. Okay, that is simple. When alkyl nitrile is treated with a Grignard reagent, you will get an adduct, that is intermediate product, and later on hydrolysis it will give the ketone. Okay. Now let us consider the preparation of ketones from aryls. Okay. Here we need to make use of the Friedel-Crafts acylation reaction. We can convert the aryls to ketones by the Friedel-Crafts. This is a well-known reaction in Friedel-Crafts acylation method. Acylation means introducing the acyl. Acyl means in RCO group or CH3CO group in the place of hydrogen. This is a electrophilic substitution reaction. This is a electrophilic substitution reaction. Electrophilic substitution reaction. Okay. Let's take a benzene. When benzene, where all the 6 carbon atoms will have the hydrogens. For example, let us take the hydrogen at this carbon. Remaining will also have the hydrogen, but I am going to select this hydrogen. When this is treated with a CH3COCl, that is called acetyl chloride. What is this? This is acetyl chloride. Okay, what is this? Benzene. When benzene is treated with acetyl chloride, in the presence of Lewis acid as catalyst, that is anhydrous aluminum chloride. Anhydrous aluminum chloride. What happens? This CH3CO plus, that is the acyl group, will replace this H. So you will get benzene COCH3. This is called as acetophenone. This is called as acetophenone, and the byproduct will be HCl. Okay, the byproduct will be HCl. Okay. Here you may also make use of the acetic anhydride, but the byproduct will be the acetic acid. Okay. Yes. For example, when benzene is treated with acetic anhydride, this one, this is called as acetic anhydride. In the presence of the same catalyst, that is anhydrous aluminum chloride, you will get a CH3, COCH3 on benzene. Okay, this is what acetophenone, but the byproduct will be CH3COOH. Acetic acid. You will get acetic acid. See here, you are using the different reagents. Okay, you will get different byproducts, but the products are same. Reagents are same. Okay, when benzene is treated with acetyl chloride, you are getting the byproduct HCl. When benzene is treated with acetic anhydride, you are getting the acetic acid as a byproduct. Okay. Here, when you take the different reagents, you will get a different byproducts. Okay. Let us see one more reaction under this. When benzene is treated with benzoyl chloride, when benzene is treated with benzoyl chloride. What is this? Benzene is treated with benzoyl chloride. When benzene is treated with benzoyl chloride, in the presence of anhydrous aluminum chloride, you can see the release of HCl, and these benzene rings will join. Okay. What is the name of this product? Benzophenone. This is a benzophenone. Okay. This is all about the preparation of ketones from arenes by Friedel-Crafts acylation. Okay. Yes. Thank you.